The question says which of the following pairs constitute resonance structure. We have to determine resonating structure. And for the resonating structure, we must have the conjugated system. Pay attention very carefully. Conjugated system, how we determine? Always keep in mind, we have double bond, single bond, and then double bond. This is what conjugated system. Again, resonance will be there. First case. Second, if we have double bond, single bond, then positive charge. It is also considered as a conjugated system. Resonance will be there. Okay, third case. We have double bond, single bond, and then we have negative charge. This is also considered as a conjugated system. Then resonance will be there. And fourth, we have double bond, single bond, then we have lone pairs. In this case, it is also a conjugated system. So these are the four cases by which we can determine conjugated system. Hence, resonance will be there. Okay. Now pay attention carefully. We have first part, double bond immediately positive charge, and always keep in mind, if resonance is there, higher the number of resonating structure, higher is the stability. That's what we have learned. If resonating structure is there, stability of the system will always increase. Okay, this conjugated system will lead to higher stability of the system. But if we have double bond and immediately positive charge, a negative charge, or lone pair is there, this is highly unstable system. Highly unstable system. Highly unstable in the sense it is not a part of conjugation, hence there is no resonance. Highly unstable system, this is not a conjugated system. Double bond immediately positive, negative, or lone pair is there. Okay. In this case, you can see double bond and positive charge is there. Immediately positive charge is there. This is not a part of resonance. Okay. It is talking about the pairs. Both the pairs should have resonating structure. Okay. Second part. In this case, double bond, and then we have single bond, then positive charge is here. Double bond, single bond, positive charge. Double bond, single bond, positive charge. Resonance is there because it is a conjugated system. Okay. But in second part, there should be some correction. Correction is required. Why? Because CH2 is supposed to have double bond. If double bond is not there, it means one negative charge is present over this CH2. Okay. Now in this case, double bond, single bond, negative charge. This is the correct structure. Double bond, single bond, negative charge. It is also considered as a conjugated system. Then resonance will be there. In this case, conjugated system, it is also conjugated system. Double, single, positive, double, single, negative. Conjugated system and resonance is there. Option B is absolutely correct. Constitute resonating structure. In this case, there is no resonance because there is no conjugated system. Then we discard it. In this case also only one double bond is there. In this case also only one double bond is there. Minimum number of double bonds we should have two. This is one double bond, this is one double bond, and they should be alternatively arranged. Then it will be a conjugated system. So this is also not resonating structure. A, C, D do not have resonating structure. In this case you can consider because here we have the lone pair. Okay, so double bond, single bond, lone pair is there. But anyway, in this case situation is different because oxygen is more electronegative than nitrogen. It has greater tendency to pull the electron density than donating electron density. So best option we have B. If you like this video, please share and subscribe to the channel.